We are now going to talk about how we actually measure energy. So before going into the details of actually measuring energy, let's first look at the units of energy. The most common unit, or the SI unit of energy, is considered a joule. And a joule is made up of all the fundamental types of units. So a joule is made up of a kilogram meters squared over second squared. And so instead of saying kilogram meter squared per second squared, we have a new unit which we call a joule. And so this is one unit of energy. Now the way one technique of measuring energy is we have to know how those molecules are moving around that are making up the substance. And one of the properties that help us measure that is temperature. Temperature has many different scales as well. And so temperature, like I said, is a measurement of how fast the thermal energy of the substance, how fast the molecules that make up the substance are moving, what their kinetic energy is. And so as that kinetic energy or thermal energy goes up, the temperature of the substance will correspondingly go up. Now, temperature, there are three very common temperature scales that you will come across. The one that you're most familiar with is the Fahrenheit scale. And the Fahrenheit scale we abbreviate with F, degrees Fahrenheit. We also have the Celsius scale. And the Celsius scale is used a lot in the sciences. And it's also used quite a bit in other countries. The United States is usually just Fahrenheit. All the other countries are Celsius, is what they use for temperature. In science, we use what we call the absolute scale. And the absolute scale is called Kelvin. Now, you will need to be able to convert between Fahrenheit, Celsius, and Kelvin. So the symbol for Celsius is degrees C, and then Kelvin is symbolized with just the letter K. We don't put a degree mark for Kelvin, so only for Fahrenheit and Celsius. So how do we go from Fahrenheit to Celsius to Kelvin? Now, really, you need to know two formulas to do this. So let's first do the simple, and let's go from Celsius to Kelvin. Now, to go from Celsius to Kelvin, use a formula that Celsius is equal to whatever your Kelvin temperature is minus 273. And then correspondingly, if you want to find Kelvin, you just take your Celsius degree and you add 273 to that. So for example, if you have a temperature of 10 degrees C in Kelvin, that would be, so Kelvin is equal to 10 plus 273. Kelvin would then be 283 Kelvin. So 10 degrees C is 283 Kelvin. And then if you have, let's say, 400 Kelvin in Celsius, what we do is our Celsius is equal to our Kelvin minus 273. So we take 400 and subtract 273 from that, and that gives us 127 degrees C. So it's fairly easy going from Celsius to Kelvin. We just either subtract or add 273. So how do you remember if you have to add or subtract? Well, one thing that you need to realize is that Kelvin is only positive. So Kelvin temperatures go from 0 on up. Celsius has negative values and can also be 0. So Kelvin will never be a negative value, but Celsius can be. And so that's one way you can always remember that to get Kelvin, you always have to add 273. You never subtract 273. Now, how do we go from Fahrenheit to Celsius? So to go from Celsius to Fahrenheit, we're going to use a formula to get Fahrenheit. We're going to take 1.8 times whatever our temperature is in Celsius, and we're going to add 32 to that. So no really easy way to remember this. Fahrenheit is equal to 1.8 C plus 32. Now you can make this a fraction of 9/5 if you want, or just remember 1.8 C. So let's do an example. Let's say we have a Celsius temperature of 275 degrees C. So to get in Fahrenheit, what we do is we just plug 275 into this formula. 1.8 times 275 plus 32. And when we put this in the calculator, 1.8 times 275 is equal to that. So 495. And then we add 32 to that. And so 495 plus 32 gives us 527 degrees Fahrenheit. To go the other way, what we do is we can kind of rearrange this if we wanted to. Another formula that you can use is Celsius is equal to 5/9 times the Fahrenheit temperature minus 32. So 5/9 is basically the reciprocal of 1.8. So what you have to do is, don't forget that this is in parentheses, so we need to do this first. So if I have a Fahrenheit temperature of 451 degrees Fahrenheit, what is Celsius? So we just plug this into the formula, 451 minus 32. Again, this is in parentheses, so we need to do that first. So 451 minus 32 gives us 419. And then we multiply that by 5, times that by 5, and then divide that by 9, gives us 232.777, or just 233, and this is degrees C. And so that's how you use the formulas for Fahrenheit to Celsius and Celsius to Kelvin. Now what about if you had to go from Fahrenheit to Kelvin? Well, you can kind of combine all these formulas, but my advice to you is to first go to Celsius or go to Kelvin first. So if you have a temperature in Celsius and you need to go to, if you have a temperature in Fahrenheit and you need to go to Kelvin, convert the Fahrenheit to Celsius and then Celsius to Kelvin. Do it in 2 steps. Or if you go from Kelvin to Fahrenheit, you want to go Kelvin to Celsius and then Celsius to Fahrenheit. That's the easiest way of going about doing that. Now, whenever we're talking about or trying to measure energy of something, we need to kind of define what exactly we're trying to take or determine the energy of. And so there are 2 terms that we need to have a definition for, and that is the system and surrounding. So whenever you're dealing with energy, you need to figure out, okay, what exactly am I talking about or trying to measure the energy of? And that is the system. Whatever you are trying to actually measure is the system. The surroundings is everything else. So what you want to do is you want to try to keep energy from leaving the system and going to the surroundings. If that is what you're attempting to do, then what you need to do is have something that's blocking the energy from going into the surroundings. And one way of doing that is by using like an insulated container. In science, we call these containers calorimeters. And a simple calorimeter would be like what we call a coffee cup calorimeter, and you might have done this in lab, where you take a coffee cup and whatever's inside the coffee cup, that is what your system is, and then the lab and the air surrounding that is your surroundings. So the coffee cup insulates or keeps all the energy inside the coffee cup, and that's one reason why we use styrofoam, because it's a really good insulator and keeps our coffee nice and hot whenever we want to drink it. The heat doesn't dissipate into the air and cool off. Now, whenever we're measuring energy or measuring heat, we need to look at what that material is made up of. And every material can absorb energy or dissipate its energy differently. And so that property is what we call specific heat. Specific heat is inherent to whatever the material it is that you're trying to measure. And so what we're going to do is to figure out how much energy or how much heat, which heat is the transfer of energy, going from the energy moving from one thing to another. We need to kind of take all these properties to measure the amount of heat. And to do that, we use what we call the heat equation. The heat equation is a very simple equation, and so it measures the amount of heat, and we symbolize the heat with letter Q is going to equal to the amount of the substance that we're trying to determine. So mass plays a role, and then the specific heat, which I'm going to symbolize with the letter C. Some places might say S, but I use C because that's kind of how I learned it. And so we have our specific heat, which again is inherent to the actual material. And then whenever energy does get transferred from one object to another object, there's going to be a change in temperature. And so a change in temperature is represented by the symbol triangle T. And this is actually a Greek letter. It's the Greek letter delta. And so we say delta T for that. And so Q equals MC delta T is what we call the heat equation. Now let's kind of do a problem involving the heat equation. So the heat equation, Q equals MC delta T. And so let's say that we have a substance that has a mass of 4.2 grams. And so that is our mass. And the specific heat of that substance is, let's just say we're going to do water. So let's say we have water and we have 4.2 grams of water. And so the specific heat of water is 4.184, and the units for specific heat are joules per gram degree C. And then we are going to have a change in temperature. So a change in temperature is always final minus initial. And so let's say our final temperature is 40 degrees C, and then our initial temperature was 20 degrees C. And so that means our delta T is going to be our T final minus T initial, which is 40 minus 20, or just simply 20 degrees C. And so now that we have our mass, our specific heat, and our change in temperature, we can plug it into this formula. Q is equal to 4.2 grams times the specific heat, which is 4.184 joules per gram degree C. And then our change in temperature is 20 degrees C. And when we do this, notice that the grams will get canceled, degrees C's will cancel, leaving the units of joules. And so let's plug this into the calculator. 4.2 times 4.184 times 20 gives us 351 joules. And so this is the amount of heat that would be in a container of water that goes from 20 degrees C to 40 degrees C. 351 joules of energy got transferred.